Good morning to all. Today we are going to discuss the concept called taxonomy of bugs. This is the second concept in the second chapter of first unit. So taxonomy of bugs means different types of bugs. So there is no universal correct way to categorize those bugs. So there are different types of bugs are there, even though there is no any universally correct way how to categorize those bugs. And what is the categorization we have provided here or mentioned here? That categorization or taxonomy is also not rigid. That means they are also not perfect. And if you give a bug or if you taken any bug, you can put it in one or any other category, depends on its history and the programmer's state of mind. That means, so there is no universal correct way for representing the category of bugs. And what is the representation or what is the taxonomy we are providing or categorizing we are giving here? They are also not rigid. If you take any bug, we can put it in any one of the category. It is depends upon the history of the bug and the programmer's state of mind. Based on this, we are categorizing the bugs. But according to our concept, the taxonomy of bugs are in major categories. There are nearly six major categories are there. Those major categories are: first one, requirements, features and functionality bugs, and second one, structural bugs, and third one, data bugs, and fourth one, coding bugs, and the fifth one, interface, integration and system bugs, and the sixth one is text and test design bugs. So these are the six major categories or bugs according to our concept. So now we are going to discuss these bugs one by one. In that series, the first concept is requirements, features and functionality bugs. So this category contains three different types of bugs. They are: first one, requirements and specification bugs; second one, feature bugs; and third one, functionality bugs. In that, the first one, requirements and specification bugs. The requirements and specification bugs occur due to incomplete and ambiguous requirements and specifications are developed. So the main reason for requirements and specification bugs are due to the incomplete and ambiguous requirements development or improper or incomplete specification development. Due to these, the requirements and specification bugs are occurred. Due to incorrect specification and requirements, analyst assumption not known to the designers. So due to these bugs, what the analysts are assuming, what is the idea of the analyst, it's not known clearly to the designer. So designer means here system designer. If the system designer is not properly designed the system, then the code may not be implemented in a proper way. Finally, the project may not succeed. So if the requirements and specification bugs are the most problematic bugs, if the bugs is there, then all the successing concepts are also failed. So this is the concept of requirements and specification bugs. Then the second one in this, feature bugs. Feature bugs are mainly caused due to problems in specifications. So feature bugs occur mainly due to the problems in specification. From the what is the previous requirement specification bugs we discussed, if there is a bug in the specification, then automatically feature bugs are arised. So feature bugs are mainly caused due to problems in specifications. So there are two possible cases. for feature bugs. So to arise feature bugs, there are two possible cases. One is mixing features. If the features are missed, there is a chance or possibility to arise feature bugs. And second one is wrong features. If you provided the wrong features to the projects, then feature bugs are arised. So these are the two possibilities for feature bugs. Then the third one is functional bugs, functionality bugs. So that's nothing but testing techniques for functional bugs. So most of the functional test techniques, so these techniques are used for finding functional bugs. So what are those techniques? They are first one transaction flow testing, and second one syntax testing, and third one domain testing, and fourth one logic testing, and the last one is state testing. With the help of these testings, we can test the functional behavior of the system. If there is any bugs, they are comes under functional bugs. So with the help of transaction flow testing, we can test the transactions, how they are flowing from one state to another state. Second one, syntax testing. So syntaxes are tested. So whether the program is developed by using a proper rules and regulations, the syntax are right or wrong. Testing these ones comes under syntax testing. Domain testing, whether we are using proper domain or not. Logic testing, the logics are implemented in a proper manner or not. State testing, whether we are executing the proper states or not. With the help of all these testing techniques, we can find out is there any functional bugs in the concept. So these testing techniques useful in testing for functional bugs, and it also useful for testing requirements and specification bugs. So this is the point of functional bugs. Then the second type of taxonomy of bug is structural bugs. Structural bug means these bugs are caused due to errors in the structure of the program. So when you develop a program, in that program structure, if there is any bugs, that comes under structural bugs. There are many varieties of categories in structural bugs. Various categories in structural bugs. They are: one is control and sequence bug, and second one is logic bug, and third one is processing bugs, and the fourth one is initialization bugs, and the last one is data flow bugs and anomalies. So these are the five different types of categories are available in structural bugs. So in that, the first one is control and sequence bugs. What is mean by control and sequence bugs? These bugs include paths left out, unreachable code, improper nesting of loops, loop break or loop termination criteria incorrect, missing process steps, duplicate processing or unnecessary processing. So when you do any improper processings, that means maybe incorrect loops or termination of loops incorrectly, any process steps are missing, any control statements are not working in a proper manner, the sequence is not correct, then control and sequence bugs are arised. So most of the control flow bugs are easily tested and caught in unit testing. So in the unit testing itself, we can find out most of the control bugs. So control bugs and sequence bugs are arise due to the incorrect implementation of control statements, loop statements, or any sequences. So this is the concept of control and sequence bugs. Then if you come to the second one, logic bugs. So logic bugs means the bugs in logic are related to misunderstanding how case statements and logic operators behave singly and in combinations. So logic bugs, so logics. So for any program development, you require logics. If those logics are not implemented in a proper manner, then it's uh, provide the way to create logic bugs. So this is the concept of logic bugs. Then if you come to the third one, processing bugs. So processing bugs means processing bugs include arithmetic bugs, algebraic bugs, mathematical function evaluation bugs, algorithm selection and general processing bugs. So processing bugs means when you processing any program, if any errors are occurred, then they comes under processing bugs. In processing bugs, some of the bugs are included. They are nothing but arithmetic bugs. If you done any arithmetic mistakes, they comes under arithmetic bugs, algebraic bugs, mathematical function evaluation bugs. So if you are not selected the proper algorithm or per process, then they arise processing bugs. So the reason for processing bugs are improper use of relational operators. If you are not properly used the relational operators, nothing but less than, greater than or less than, equal to, greater than or equal to or not equal to, these relational operators if you are not properly used, and this is also one of the reason for arising processing bugs. So if you are in the process, if you have any bugs in the process, means it may be anything, any mathematical function evaluation or any algorithm selection or any arithmetic operations, if they are not properly done in the process, then processing bugs are arised. Then the next one, initialization bugs. Initialization bugs means if you are not properly initialized any variable, if you are not provide proper values to the variables, then initialization bugs arise. According to our concept, what is meant by initialization bugs? Means initialization bugs are occur due to improper and incorrect initialization. So due to incorrect initialization bugs are arised. The typical initialization bugs are forgetting initialize workspace or registers. So we have provide the variable to the program, but we are forgot to initialize that space. So such type of bugs and forgetting initialize data areas before use. So when you want to use any variable in the program, before using that variable, you want to declare that variable and you want to initialize that variable. So if you forget, then those all things are the chances to create initialization bugs. And when you come to the last bug in structural bugs, is nothing but data flow bugs and anomalies. So this means the most initialization bugs are special cases of data flow bugs. So data flow bugs are occurred from initialization bugs. So initialization bugs are the special cases for data flow anomaly bugs. Data flow anomalies occurs due to different ways. One is using an uninitialized variable. If you're using an uninitialized variable, then there is a chance to get data flow anomaly bugs. Then second one is attempting to use a variable before it exists. Before existing the variable, if you used that variable, it also create data flow bugs or anomalized bugs or data flow anomaly bugs. Then the next chance is modifying the data and then not stored or used in the result. So if you modified any data before storing that one or used in the results, it creates data flow bugs or anomalies. Then the last one is if the initialization is twice with an intermediate use, then it also creates data flow bugs. So you initialize the data or one variable. For example, if you initialized one variable, again if you initialized without using that variable, then it also create data flow bugs. So these are all the 5 different types of bugs available in structural bugs. Then the third one in the taxonomy of bugs is data bugs. So data bugs means so whatever the data we are providing for the development of projects, if the data may contain any bugs, they are comes under data bugs. So according to our concept, data bugs include all bugs that arise from the specification of data objects their formats and their initial values. That means, so to develop a project, what are the specification of data objects we are providing? If there any bugs are there, then there is a chance to arise data bugs. Then the next fourth bug in taxonomy of bugs is nothing but coding bug. So coding bug is nothing but bugs which are caused due to the errors in the coding or source code are known as coding bugs. So what is the code we are developed, or what is the source code we are used for any program or project? If that code may contain any errors, there comes under coding bugs. If a program has many syntax errors, then we should expect many logic and coding bugs. So in the program, if you have many syntax errors, then automatically we can expect there may be many logic and coding bugs are there. So when you develop any program, you must take care on the syntaxes. Then the documentation bugs are also comes under coding bugs, which may mislead the maintenance programmers. So documentation bugs are also comes under coding bug itself. If you are not developed a proper documentation, if the documentation contain bugs, that one misleads the maintenance programmers. So after develop the program, so we need to maintain that one. So how these maintenance are going on is based on the what is the documentation you are developed when the program is when the project is developed. At that moment, what is the document they developed for that project? Based on that, the maintenance is going on. If the documentation contain errors, then it misleads the maintenance programmers also. So this is the concept of coding bugs. Then the next one in the taxonomy series is interface, integration, and system bugs. So in this concept, we have three different types of bugs. One is interface bugs and integration bugs and system bugs. In that, first we are going to discuss interface bugs. So interface bugs are broadly classified into two types. They are first one internal interface bugs. What is meant by internal interface? So external interface. Two types of interface bugs are there. They are first one external interface and second one internal interface. So in that first one external interfaces bugs. So first, what is meant by external interface? External interfaces are one which are used to communicate with the outside world. For example, if you are developing a project, inside of the project any communication wants to make, it is possible only through internal interfaces. Apart from that, if your program wants to communicate with external devices, so you require external interfaces. For example, if your project wants to communicate with any drive or any printer or scanner, if it is possible only through external interfaces only. So such external interfaces are one which are used to communicate with the outside world. So in the outside world, this includes devices, sensors, input terminals, printers, and communication links. These are all comes under external devices. If you want to communicate with these devices, you require external interfaces. If those are not proper, if those are not proper, then automatically external interface bugs arises. If that external interfaces are not properly work, then automatically external interface bugs arises. So this is the concept of external interface bugs. Then the second one, internal interface or internal interface bugs. So before discussing the internal interface bugs, the internal interfaces are in principle not different from external interfaces, but their internal environment is more controlled. So external interface means if your project or program wants to communicate with the external things, you require external interfaces. Internal interfaces means it is also similar. like external, but slight difference is there. It is communicate with other components. For example, in your project, you have two or three components. So if one component wants to communicate with other component, you must require internal interface between these two components. If this interface is not properly worked, then automatically there is a chance to arise internal interface bugs. So this is the concept of internal interface. So in the interface bugs, we have two types of interface bugs are there. One is external interface bugs and second one is internal interface bugs. Then if you come to the second one, integration bugs. Integration bugs are occur when different components are integrated. For example, if you take a project, the project may contain number of components or modules. So if all those modules are combined or integrated into a one system, then only behave as a total project. In that integrating those different components into one, if the integration is not properly done, then there is a chance to arise integration bugs. So integration bugs occur when different components are integrated. If they are not properly integrated, then there is a chance of getting integration bugs. The smaller components make use of many interfaces, because of which there are more chance of integration bugs to occur. In your project, you have number of small components. So if you want to use them, you must require many interfaces. If there are number of interfaces are there, there is a chance of getting integration bugs. So these bugs arise from the difficulties or inconsistencies exist between the components. So if there is any difficulties or inconsistencies exist between the components, then integration bugs are arised. So this is the concept of integration bugs. Then if you come to the next one, system bugs. System bugs means system bugs are revealed when system testing is performed. When the system bugs are arise means whenever the system is tested, there we can find out system bugs. So here system means nothing but the total project. The total project, if you tested, then there is a chance to get system bugs. So system bugs occur when there is a complete integration between different components such as system, hardware, data and operating systems. So system bugs occur. When the system bugs can occur means the complete integration between different components. If all the components are integrated and if you tested, then system bugs may arise. So system bugs are very expensive to fix because of its complexity. So system bugs are very expensive one because it is a large system. So in that, if you find out the bugs to fix that one, it is very difficult. So this is the concept of system bugs. Other than this, we have some other bugs are also there. Those are nothing but hardware architecture bugs. So when you develop any hardware architecture, if the architecture may contain any bugs, then the hardware may contain errors. So those are all comes under hardware architecture bugs. Then operating system bugs. So the bugs which are existed in the operating systems, they are comes under operating system bugs. Then software architecture. When you are developing any software, if the architecture may contain any errors or bugs, they are all comes under software architecture bugs. So this is the concept of interface, integration and system bugs. Then when you come to the last taxonomy of bug is nothing but test and test design bugs. So these test and test design bugs are occurred due to improper behavior of the system. Even though if you have a correct specification is there, So this type of improper behavior or this type of improper behavior bugs are occur due to the uncorrect test and test designs are there. So these are all comes under test and test design bugs. So what they say about this, through the specifications are correctly defined and implemented. For example, for any project, if the specifications are correctly defined and implemented, even though the software behavior is incorrect. So where the bugs are in the test. So if you are not designed a proper test, then those bugs are comes under test and test design bugs. So specification is right, is correctly developed and implemented, even though the bugs are there. So where the bugs are arised means test environment. So such type of bugs are called as test and test design bugs. So what are the remedies for testing for test bugs are, first one, test debugging. Test debugging means, so which test we are used to test the software, those tests must be tested again and debugged that one. So debugging means finding the errors and rectifying the errors. So in the test, is there any errors or not? Test that test again and find the bugs and correct them. So this is one of the solution to avoid test bugs. Then the second solution is test quality assurance. So before applying the test on the softwares, you want to find the quality assurance of the test. There we can find out most of the test bugs. Then the third solution is test execution automation. So the test execution, when you apply on the program, how the test is executing, that one is automated. Automated means you want to develop, you may not do the test manually, you may do the test automation. That nothing but write the program and execute that one. What is the result it providing? So that comes under automation. So test execution automation is also one of the solution for test bugs. And the last one is test design automation. So when you are designing, so always test bugs are arise due to improper design of the test. So that's why the test design itself you want to automate it. So when you follow these remedies or solutions, you can avoid most of the test bugs. So this is the concept of test and test design bugs. So these are the concepts of taxonomy of bugs. So finally, what are the points we need to remember in taxonomy of bugs means there are six different major categories are there. First one, requirements, features and functionality of bugs, and second one, structural bugs, and third one, data bugs, and fourth one, coding bugs, and fifth one, interface integration and system bugs, and the last one, test and test design bugs. These are the six major categories in taxonomy of bugs. Thank you.